Welcome to the fourth part on this new blog series, Building AI Agent-Driven Solution to support ERP and SaaS applications. In our last three videos, we have seen a brief demo of the product and business case we are working on, and we also set up our development environment. If you haven't watched those, please take some time to watch those videos and get familiar yourself with the product we are building using AI Agents framework. In this video today, we are going to write lots of code. So let's take a minute to understand the solution design we have been talking about. So as you can see, initially we talked about that creating tools, different agents. So for example, tool filer is one tool, and tool DBs there are two tools, and PDF and Tezrak there are two different tools, and each tool or more than one tool are tied to one agent, which is eventually tied to a team. So let's take one example. In this example, we are going to build the first tool, which is tool filer, is going to be attached to an agent, and agent is going to be attached to the team. So, if you can, talk about if you can write the code for one tool, everything else is so easy. So first, like to understand what the team filer tool does. What it does, it takes a file name as a parameter and it returns the file metadata. For example, file size, file owner, those kind of a thing. So let's see that example. Let's open a terminal window here. Please make sure that you are into your Python virtual environment. And here I'm going to browse to a directory called Gen AI backup. All right. So I want to show you that I already have a file called blurred_image.jpg. It's not an ideal file. Let's open this up. So code blurred image. As you can see, this file looks like this. It's a random file. But the point is, suppose you have a file in one of your directory and you want to know the metadata of the file. So the whole idea is we are going to write an agent which tells you what this file is, what the name of the file, what the file size, those kind of a thing. So let's start with creating a blank file called touchmain.py. Again, you can write all of those code into your Jupyter notebook, but because we want to execute this script as a as a command from the command line, that's why we are writing it like this. Okay, so now let's go browse to this file called code main.py. Again, first starter point, if you go to their AutoGen documentation version 0.4, here's just some code. I'm going to copy it over again. Please don't mind, I'm not going to write the entire code from the scratch. I'm going to make use of the code wherever I can get it from. So but let's just take a minute to understand what this code does. First, it assumes that you already have couple of packages installed. So for example, AgentChat or AutoGen models, etc., which we already covered in last video. So I'm not going to do that again. Okay. So next thing is, if you go to my previous version, I have all of these things: how to create a Python environment, how to set up AutoGen, ollama, DeepSeek model, everything I have covered in detail. So I assume that you already have that. Next thing is, so please go through, take a minute, like what each package does. So async IO is going to create an asynchronous, command line chatbot kind of a never-ending kind of an interface, so that you can talk to your agent. So that's all it does. You can, if you want to run it from through other mechanism, please feel free to do that. Couple of other packages like assistant agent, as you might have guessed, it simply helps you create an agent. And OpenAI chat completion client. Actually, this is what it is, a glue between your agent to your Llama models or DeepSeek models. We are going to refactor the entire source code from the beginning again, but I just wanted to quickly show you how to get started. Now, if you save this and run this, I'm pretty sure that you are going to, when first timer, it's not pretty. It's not, you are going to see a lot of errors here. But let's run this, okay? And once we see the error, it's a learning process, so you will understand why each things are happening, and these errors are going to help you better understand how things are arranged here. So as you can see, first thing, if you run it, it gives you a couple of error here, but if you look closely, all it says that there's something wrong with the OpenAI key. And by default, as you can see, because if you look closely, it says OpenAI key environment variable is missing. The whole point is, when you are running it a vanilla version, it expects that you already have OpenAI API key ready. Now, if you already have OpenAI key subscription, you can stop watching right now. Just pause the key, everything else is going to work beautiful. Okay, but the whole reason I'm creating all this tutorial is I want to make this work for my locally hosted machine. That's the reason I'm going through this entire pain. So I'm going to comment everything out again, and I'm going to start it over. All right, so let's start again to write this code, and I'm going to refactor this code so that it works on my locally hosted ollama or DeepSeek R1 models here. So a couple of packages, I will already need that. So let's go re-import the async.io and the agents and OpenAI chat completion client. these packages are still applicable. So for example, I want to run this whole program asynchronously. So that's the reason I have got this import async IO. Now I'm going to make use of the same assistant agent. So let's go redefine that function. So as you can see, I have my main function here. What it does, it creates an agent, assistant agent. I just want to I would like the keywords parameter here. So I'm just going to append it by saying name equals to assistant. Now let's go change this name. So the whole thing is we are writing our first agent and the name was agent underscore filer. So let's go give it a name. So instead of just saying assistant, so I'm writing my first agent, agent equals to filer. And then second, this assistant agent method, it expects name and the model client. So I'm going to separate this code. So let me write a model client equals to, which is an instance of OpenAI chat completion client. So I'm going to control X, put it here. So I'm just like separating the code, so that it's easier to read. Okay. So as you can see, OpenAI and here, let me go back and read the signature. Anytime you are in trouble and you want to know something, read the signature of the function. So as you can see, there are two, name and the model client. These are the two parameters is assistant agent is expecting. So name and let's say model client, model underscore client equals to model underscore client, which we are going to define in previous lines. Okay, so now here as you can see, OpenAI chat completion client. So here is expecting that you already have a GPT-4o model, which that's the whole reason we are doing it, because we want to use our locally hosted model. So if you read the signature carefully, as you can see, it's expecting an API key. If you don't already have that, you is expecting to set it up at the environment variable here. Okay, so we need to get rid of that. So let's go read. I'm going to clear out all the terminal screen. So because we want to use our own model, so let's go list out ollama list. So it will tell you in my machine right now I have a DeepSeek model, Llama 3.2 model. So I'm going to use one of those two models here. So by default, ollama, when you run it, it serves at one certain post. So if you go in HTTP localhost and serve, check your port number 11434. Again, it might be a little different, but this is where the ollama host serves. So if you have a ollama working on your machine locally hosted, all you can do use this URL and it will make it work. So let's go first change the model, say DeepSeek R1 model here, DeepSeek R1, and because that's the most popular nowadays. And second thing, as you see, I'm still using the same interface given by OpenAI chat completion client. There's no new interface, so that's the good thing about it. If you read the signature, all is saying model, and if you don't want to use OpenAI GPT-4o model, you can give your base URL here. So base URL, and I'm going to pass the ollama URL what we got. Again, by default, because my ollama is serving at port number 11434, all I can do, I can pass the URL here and it's supposed to work. Just a hint, it's not going to work, but I'm just telling you the steps, so that you know. Second thing is API key. We don't need API key, so we'll just say placeholder. And the model info. Now, again, you have to pass couple of the default parameters. So for example, this is not a vision model. Function calling equals to true and JSON output equals to false. And you can pass the family here. Again, we are going to review this. You will see the details why we are doing it like this. So just to recap, function calling is the most important thing here because we want to use tool functions. So make sure function calling equals to true. Let's go back to our assistant agent. So model client equals to model client. Okay, now here you can pass the tools equals to tools, but I'm just going to comment it out. I can tell you from the right now, this function doesn't work with ollama. And you will see that why we are doing all this hassle, because the problem is ollama tools support is not yet there. Okay, so let's go run this file again. I'm expecting a lots of error. So as you can see, 404 page was not found. So simply, first thing what you learn that if you're trying to access ollama like this, if you just pass the ollama 11434 locally hosted, it doesn't work like that. Okay, so what we need, so that's the first hassle. So to get over it, what you will need here, you can always test it out. So if you go to open a simple browser window and try to access that ollama model through this interface localhost 11434, it might work. You might have some other thing, but I'm just going to show you how to create another API based model. So, and this is the beauty of it, you can use not only ollama, if you have something else hosted, you can always use that. So to do that, we need a proxy server in between. So let's go install something called litellm proxy. Again, the job of this litellm proxy server is going to create a proxy server between your OpenAI AutoGen to the other API based ollama models. So again, just to recap, what it's doing is just a simple interface which converts your AutoGen API understanding to the locally hosted ollama model here. So it's just working in kind of an interface kind of a thing. All right. So make sure that you have installed that. Pip install litellm proxy. I already have that, so I didn't do it again. Okay. Now let me run it from a, you can always run it from terminal window, but I'm going to run it from another terminal window, or let me run it from Jupyter Notebook. To run this, very simply say litellm -, model and pass the model name. Okay, so you can run it from terminal window here, but because I need terminal window for other purpose, so I'm going to do it from other Jupyter Notebook. You can pass, suppose you want DeepSeek R1, so just say litellm -, model and give the DeepSeek R1, or if you want to Llama 3.2 PHI model, or any model of your choice, it doesn't even matter. That's the reason we are using this litellm. It gives you a flexibility to run any choice of model independent of your AutoGen framework. So please appreciate that. All right. So here, because we already have running this, so all I need to do, my base URL is changed. I'm going to change the base URL to port number 4000. I already have this running here. Let me, because I need a terminal window, I'm going to run this from Jupyter Notebook. So let's go back here, and here I'm going to run this from Jupyter Notebook. Please wait, make sure that it's already started and you see that message that your host server is running. Okay, now let's go run this main.py file again one more time, and if everything is all right, it should execute. Which again, depending on your luck, I am 100% positive that it's not going to work. But okay, all right. I think it's complaining about the model family. So let me uncomment this model family .r1, and I see, as you can see, there are couple of mismatches here. I want to use the model Llama 3.2 because DeepSeek R1 doesn't support tools yet. Okay, so let me just, and I was running DeepSeek R1 model there, and there was a mismatch. Okay, so pardon me about that. I'm going to comment out the DeepSeek R1 because it doesn't have the tool support yet. Okay, I'm going to execute Llama 3.2. So let's start fresh, run this model here. So now we have a litellm model which is running Llama 3.2 version. Now let's go back to main.py here, and I'm going to change the model name saying Llama 3.2. Okay, and the family is still family equals to model type equals to family R1 is still commented. If you run this again, now it's complaining about, because I think for some reason I still think that there's a model family.r1. So now let's go. I'm going to uncomment this and let's import the package, because it's complaining about the model family. I think it might be is overriding some default somewhere else. So it's better to pass the model family right now here. Okay, so model family.r1. Now let's go try to run this again. Please see that I'm intentionally, I have done this before. I know exactly what's wrong with that. I've gone through hours and hours of pain. So that's how I know that what is working, what is not working. But I'm intentionally making this mistake so that you can see the debugging process here. Now again, family, if I'm passing that family JSON parameter saying model family.r1 and I'm saying Llama 3.2, there's a mismatch. Okay, so obviously either you comment out this one or you make sure your model is pointing to the right litellm model here. Okay, so here as you can see, let me pass that model parameter inside that model info one more time. I hope that's the mistake. So now let's go run this one more time. Let's try DeepSeek R1 one more time. I know still it doesn't support the tools yet, because DeepSeek R1 model, we are still going to use it. It doesn't mean that just because DeepSeek R1 is not supporting tools, we are not going to use it. It's a good model. It's a very, very good reasoning model. So I want to make sure that I am able to access DeepSeek R1. So let's go run this one more time, and I'm going to run the make sure that is your server, your litellm's proxy server is running, so that your base URL is active. Now let's go run this one more time. I hope everything matches now. Make sure that your model name, base URL, and the model family, everything matches. And I'm going to, comment out all these things. Just simply print hello world. All right. So if you run this, if everything goes well, see now it's working. So I have got, that means it's sure there's no more error. That means my main.py file is able to access the litellm model, which is running that model DeepSeek R1. Okay. Now I think we are at the stage, because we don't know, the problem is we have this image we want to read, okay, and we need to write a tool functions which can read the metadata of an image. So the whole point is we need to write the tools function which we can use inside the agent, and eventually that will report to the team. Because we have so many tools. We are writing PDF tool, Tesseract tools, all of different tools. So again, what I'm going to do, and you can see this whole tutorial is about writing tools. Creating, running in a LLM model locally hosted in your machine is not a big deal. We want to automate the whole thing. That's the reason we are doing this. So again, let's go, I'm going to, refactor this code a lot of places here. So tools equals to tools. First, you have to understand how to define a tool. So again, I have covered this topic like in extensive detail in the past. But again, so this is, for example, there's an example of the tool. Here I have imported couple of packages here. All these packages do, if you pass a file name, it takes that file name and it uses all those packages to read the file metadata. So given a file name, it will tell you file path is this, who is the file owner, file size, and what is the file type here. We have covered why we need that, but it's a simply tool is nothing but a Python function which does something. And then once you create that Python function, you wrap it around to the tools function. That's how you write tools for ollama hosted models here. Again, if you're interested in this topic, I have covered this topic in extensive detail. So if you go to my YouTube channel, there is a playlist. This is like, if you want to get started for the Gen AI RAG based model here, I've covered this topic in extensive detail where it talks about like how to create tools for a locally hosted, how to do the function calling in ollama. I have gone through this each and every step in very much detail. So please go through the tutorial. It will help you a lot. So now let's run this function. I want to test out this function here. So I'm just going to say execute this. Is it still running? No, I think sorry about that, because I was running light LLM on my Jupyter notebook and it can execute one cell at a time. So I have to go stop this first. Now let's go stop it. And now let's go test out our function here. So I'm going to run this. As you can see, it worked pretty good here. So now we have got a file here, but basically we don't need to, do all of these things. So I'm just going to copy paste this. So let's go copy this one function here. Okay. And I'm going to, just copy this one function, go to .main.py, paste it here, because this is the tool function. So we are defining one tool function here. Copy paste this thing here. I think I will also need those packages. So OS, PWD, mind type, and chat utility. All right, let's go import those packages here. Okay, now I want to test out this function. So basically, what I want to do, take this function definition and pass a dummy file name. So in this case, let's say get file metadata, and inside this I'm going to pass that file we are talking about, blurred image. So that file is in the correct directory here. So blurred underscore image.jpg file, and I'm going to print this out. So blurred image.jpg, and I'm going to wrap this inside that print function. Let me paste all of this. Sorry, let me just comment all the rest of the code so that I can just test it out. So print, let me wrap this inside that print. Okay, save this. Let's run this again. Process directory. Oh, because okay, I'm going to comment out one line code. This code is irrelevant anyway. So it just renames the file here. So I don't need that file. So let me save this. Let me run this again. So as you can see, it tells you file path is this. Again, is this doesn't look good. So I think I forgot to format the string. That's why it's not reading the parameters here. Let me save this one more time. Run this again. Python3 main.py. See, now it's able to read the file name and it tells you exactly who is the owner, what is the file size, and what is the file type. So that's how, this is a working function, and you are going to end up writing such functions over and over again. That's all the AutoGen agents is all about. Please try to, practice this as much as you can. All right. So we have got one function here, and later on, as you will see, this code, what I just shown you, this code, is still very, very important. Just because ollama tools functions calling is not supported yet, it doesn't mean that by the time you're watching this video, you might figure it out that my code is not working, right? So you have to go back. Please make sure that you already have that code, you understand how this code works here. And to wrap it up, you define the tools and you define a function tool class and you pass that tools inside that. So please try to go through that, and by the time you're watching this video, the chances are this thing is in active development phase. So AutoGen might have released the function call tools. So if that's the case, you don't need to watch the rest of the video here. Simple. You can stop here. That's how you define the tools and pass the tools to the assistant agent. You're done. You don't need to do any of those things here. This code is not required. So that's the problem. This code, as of now, as of today, I'm recording this February 12th. Okay. Unfortunately, this code is not working. So I'm going to comment it out. But I'm still going to, you can find this code in my Jupyter notebook here. Okay. So now let's go learn another, trick, because this code is not working. We have to, get the work done here. Okay. So we have defined a tool function here. Okay. Now let's go uncomment this out. Now we have defined the tool. Unfortunately, we just cannot do tools equals to tools. Otherwise, that would have made our life very, very easy. So we have to find the workaround solution here. So again, if the tools is supported, sorry, I keep on repeating. If the tools is supported, please check with AutoGen documentation. You don't need, you can stop here watching the rest of the video and it's, but it's not supported yet. Let's go make it work. So I'm going to comment it out. Let's go redo, I'm going to not redo the entire thing. We have to refactor the code. So far what we have done, we have defined one tool function here. Now let's go define an agent. So again, I'm trying, just a different syntax here. I'm defining a new agent called assistant agent. And inside that, if you remember, there are two things it takes: name and the model client. So name, I'm just going to give it a name saying chatbot. And let's define the configuration again one more time. So we have done that before, but it also takes a system message here. So system message is like, think about, you might be familiar with, it's just the direction, just the guidance you are giving to your LLM. So here, because we are creating a chatbot, we are saying, hey, you know what, how do you tell your LLM model that, hey, go use a function? So that's how you tell. So in system message, you can say, hey, for all file management prompts, please make sure that I'm going to give you a function, use that function. That's basically all you're doing here. It's very, very important. Otherwise, your hosted model is not going to understand. Okay. So you make sure that you pass this as a system message here, and then you can pass the tools here. Okay. You can directly pass the tools, but we are going to work around is not that important here. Important point is how you tell your agent to make use of a tool. Again, just to simplify, so all the local LLM configuration, I'm going to write those in a separate variable here. And the reason I'm doing it so that you can easily switch from one model to another one. Again, the model is not required here. Okay, so in past we have written all the model API key and like that, but here you don't need to do all that again, because when you're running your light LLM model here, you run it like this. Here you are already passing the model, so you don't need to do that. Let me pass the run one time. So for example, light LLM model ollama llama 3.2. Here I'm saying, hey, let's go run llama 3.2 model here, and it already knows that. So there is no point to run to it doesn't hurt, but there's no point to pass the API key and model one more time. But make sure your base URL is correct. Base URL should point to your light LLM where you're hosting and serving your LLM models here. Price token, again, because it's free, is locally hosted. That's why 00 and cascade equals to none. Okay. So that's the whole point. You are running a locally hosted AutoGen configuration entirely on the machine. So there's no price tag. Only thing you need is a base URL. All right. So now, as you can see, I have defined a chatbot, very simple chatbot, which is the assistant agent here. That's the problem. Now you have to define a proxy server here. I'm going to borrow some code. So if you go to your documentation, just type light LLM. That will take you to a they have created a sample, very nice of AutoGen people to do that. Otherwise, this code was very, very hard. Even I just for hours I couldn't debug it. So what this code shows you how to create a proxy agent in between. Okay, so I'm just going to copy that. They have and whatever code I'm showing, I have refactored this code using this code. So please go through that documentation. But in this code, you need something, a glue in between, which takes your assistant agent and tied it to the actual llama code, llama model here. So this is the proxy. You have to create a user proxy in between, and you will see that in a minute why I need that user proxy. So let me paste it one more time. So user proxy, and it accepts a couple of parameters here again. So I think user proxy equals to AutoGen user proxy agent. Okay, so these are the default parameters. Once you copy paste it, you do not need to change it over and over again. Okay, I think it's giving you error because. All right, we will fix that later. Now you have this proxy agent. So you have to, so remember you just created an assistant agent. You have to take that agent and pass it to your proxy agent. So first thing you say, we are going to write some macro function here. So we'll say, hey, user proxy, register for execution, and then you register for LLM. Okay. So you register your proxy. and then you take your assistant agent what you have created, you register for LLM. These are by default, the default function here. And then you create the tool function and pass it to your assistant agent here. It's a little hard to understand. First you created a user proxy, you registered your user proxy, you registered your agent, and now you are registering the tool function. It's a 3-step process, but it's very, very simple, and it's not going to change. Once you define it, you can use it over and over again for the rest of the things. Now it's time to define your prompt. So here I just want to say, hey, you know what? I want to find the file size of, again, initially we were passing this as a hardcode parameter. Now I'm not doing it again. So simply I'm just chatting with my chatbot saying, hey, I need to file the file name for this file. Okay. And rest of the code remains the same. So here initially, we are using our main function to use that async IO, but here I'm just going to, instead of directly, creating an agent interface, I am going to use the user proxy. So say user proxy dot initiate chat and pass that agent there. Okay, and pass that prompt there. So here I'm just creating wrappers around that so that it's more dynamic and user, is user oriented. All right. So I think it's still giving error. I forgot to import the AutoGen package here. So let's just say import AutoGen. Hopefully that will fix all these problems here. Import AutoGen. Let's go to, okay, the error is gone now. Okay, that's all it takes. Okay, so simply we created a user proxy, we created an agent, we created a function, we registered user proxy, we registered the agent, and we registered the tool function attached to that agent. All right, so that's the chronology. Okay, that's the path, that's the flow. Okay. Now let's see, and now everything is going to be dynamic. Here I'm going to, now you can use this, change the prompt and make it work for a different file. All right, so now let's go save this and run this one more time. And hope everything is all right. No, it's not all right. Okay, so it's talking about unexpected argument LLM config. Okay, I think, okay, because we imported the AutoGen, so we have to change this. So just say AutoGen dot assistant agent. Here I'm not invoking the previous assistant agent. Here I'm just using the direct imp AutoGen package here, and I'm using the assistant agent and the AutoGen package here. All right, so as you can see, now if you hit enter, it will tell you, first it displays the prompt, it tells you what exactly the tools is using, and it returns the results of the tools, and then it displays the results. That's something what you want to achieve in this whole tutorial. Okay, now you're passing a dynamic parameter. It understands, hey, this what tools to call. It calls that, accesses the appropriate function, pass that dynamically those parameters, and then it returns the results. So again, once you see this in action, it's a lot of work, but it's definitely is worth it. Okay, so I think now we have this working. The only thing remaining is it's not very nicely formatted, but your code is working. It knows what your dynamic prompt is. It reads the prompt and it creates the function parameter, take those parameter, pass it to the tool function, running those tools, and then getting the results back. So it's an end-to-end process you are able to achieve. All right. So similarly, as you can see, we have written only one tool. Okay, but let me, I think, one more missing step here is to nicely format it. So what I'm trying to tell you, let's just create an ollama, wrapper function here. Again, this is nice to have, is not required for the exercise, but I just want to show you, see that so the whole, it knows what the file path parameter is. It knows it can read that file name from your prompt, and it's giving you the answer. It's running the tool function, but still, I asked a simple question, hey, what is my file size? Why you're telling me all this information, right? So I need something in between which can nicely format the answer in English language. So what you can do here, simply just say import ollama somewhere here. So let's say import ollama, and I'm going to create a wrapper function saying, generate llama response. What this function does, it takes the prompts, it reads the context, it nicely format it out. So it says, hey, here is the question I'm asking, and here is the result from the tool function I received. Can you give me an appropriate answer? So basically all this function is doing. Simply I'm just creating a wrapper, is simple, and here you can, choices are endless. Here you say, I just want to see the file size. Don't show me all the garbage or other things. You can write it like this. Okay. So simply, you can create as many such functions, nicely formatted, define your context, define your system messages. That's the reason you can create. I'm creating all those LLM wrapper here. So now basically I'm getting all the response from the agent. So I'm going to, wrap it around. I'm saying, generate llama response and say prompt, and then you pass the result what we received from chatbot here. So prompt chatbot.chat messages. Chatbot.chat messages here. This is entirely optional. So if this confuses you, please don't do that. All right. So now if you run this, we have successfully created an agent which can read the file name from the prompt, and it can run a tool function, and it can get the results back, and it can nicely send those results back to you. That's all I wanted to achieve. Now let's go, sky is the limit. Now you have the job is not done yet. We have many different functions to write. So there's a PDF function, test-direct, vision, databases function. So let's go, let's do one more exercise so it will make it more clear to you. So for example, I want to create another tool function. Let me just get rid of all of these things here, okay? So I think these things are not required. So I'm just going to, delete all those comments. Okay, those are still very important. You might need those later, okay? But just we can always recreate those, okay? So now let's go create one more tool function just to make sure that we got the grasp of understanding of this whole process here. So just like the file metadata, I'm going to create, say, another tool function which say let's call it a tools2. What it does, simply it reads the content of a PDF file. Okay, and here you can use PyPDF or test-direct. That doesn't even matter, okay, because that's your insight. That's the function you have to write based on your infrastructure available on your machine. Simply what I'm going to say, what this function does, if you give it a file, it reads the PDF, and it generates the PDF content, and it returns the PDF content back to you. So again, just to reiterate what this tool function does, its job is very simple. Its job is to read the content of a PDF file. It doesn't matter how. Okay, it can use PyPDF, test-direct, or it doesn't matter. Okay, but its job is to create this function. Let's call it a tool_PDF. So this tool function reads the content of the PDF file. First you define the tool. Then this doesn't change. You don't need to change your local config here, but you need to create a different agent. Remember that. So initially we created previously we created an agent called chatbot. Okay, now here I'm going to create another agent called PDF_agent. Okay, I'm going to copy paste this code. Okay, make sure you give it the name is correct. So I changed this name. This agent is read the PDF agent, and here you have to be specific. So change the system message accordingly. So I'm saying, hey, you know what? This agent, what it does, it reads the content of a PDF file. Okay, now user proxy doesn't change, but user proxy has to be there, but now you have to register your agent. Okay, so now let's go copy paste this, and I'm going to register so simply say pass the name of the agent what you have created, change the description. Okay, I'm saying PDF reader. Okay, and now the tool function what we have just created, you have to register that tool function to this agent, otherwise it's not going to work. So just say get PDF data, and let's change this. So what is the function we wrote? So we wrote this tool_PDF. Okay, so make sure you pass that function what you created as a tool function to this agent. All right. So that's how, see how simple is that? You can create as many agents as you want. Okay, first define the function, create an agent, take that function and register it to that your agent, and then you run it. Okay, now I'm just, for example, you can have a different prompt here. So let's say prompt 2 says, you know what, read the content of this PDF file. So you say read the, and it could be any PDF file. So you say read the content of a PDF file, and it will know like what PDF file. It will find out that PDF file in your current local directory here. Just a sample.pdf. Okay, so because it knows how to read your prompt, and it had to create fetch the prompt value, the functional parameter values from your prompt. Okay, now simply because this is a different agent, make sure that when you're running the conversation, you change the prompts and you show the PDF prompt nowhere. Okay, so I think that's you got the idea. I'm not going to cover all the agents, like I'm not going to write all the agents in this video today. This is already a long video, but the whole point is I'm going to finish off, but you will see that if you write only one tool function, one agent and one team appropriately, it's very easy, and then you can copy paste the entire source code. It's all about creating different functions and registering those tool functions to your agents here. I think that's all I wanted to cover in this video. This was a long video. I might have done a lot of mistakes in this video, and a lot of things might change as you are seeing this video by the time you are watching this video. I hopefully, in near future, AutoGen releases their tool functionality so that we don't need to do all these hassles again. But as of now, unfortunately, this is what it is. It's not that bad, you just need to know some tricks and tips to make it work. All right, so that's all I wanted to cover in this video. But again, what we are doing here, we are just creating the foundation. We have just scratched the surface only. Okay, the whole reason I'm doing this video, once you understand how to create tools, agents, how to access your locally hosted model here, sky is the limit. In next coming up videos, you will see how I am going to use all of this AutoGen functionality. And if you browse to my GitHub repository, you will see that this is like, so far we have covered only the basic. But once you understand the basic, there are a lot of use cases. For example, time expense monitoring system, HR help desk, autoresponder. So you will find these tools and functions, agents everywhere. Again, all of this code what I have covered today, you are going to find this entire notebook over there, and all the codes is written over there. But there are a lot of things coming in near future where I'm going to write professional applications like time expense or monitoring, HR help desk. There are a lot of things we are still need to cover. And that's all I wanted to achieve in this blog today. I wanted to quickly show you how to build AutoGen teams, models, tools, functions, and AI agent, etc. In the next blog, we are going to use Agent Studio to implement the same thing.